Welcome everyone to Back to School with CORE and GENESYS, presented by Zane Scott. My name is Donna Long. I am the University Program Coordinator and will be the host during today's webinar. As Vice President of Professional Services at Vitech, Zane Scott manages the company's consulting and training organization. For the past 25 years, Zane has built a skill set that enables him to provide insight and guidance to individuals and companies as they improve organizational processes and methodologies. Zane has also taught systems engineering methodology in a variety of settings, is a frequent blogger, and is co-author of Vitech's book, A Primer on Model-Based Systems Engineering. With a professional background in litigation, Zane is also a trained negotiator, labor management facilitator, and mediator. He has practiced tactical negotiation and intervention mediation and taught communications, conflict management, and leadership skills at both the university and the professional level. Before joining Vitech, Zane worked as a senior consultant and process analyst, assisting government and industry clients in implementing and managing organizational change. Before Zane gets started, I have just a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Zane will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be made available within 1 business day. The recording will be published to Vitech's My Support webinar page, located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you would like to see covered in future webinars. Now I'm going to turn the presentation over to Zane. Welcome, and thank you for joining us.
Thanks, Donna. Donna's being a little bit modest here. She's not only going to be the host, but she is going to give us a high-level survey of Genesis when we get toward the end of the webinar and share with you some of the feature set. A lot of you I know that are seasoned instructors who have already contacted the program, but we wanted to just simply do an introductory webinar for starting back to school and talk about some of the fundamental concepts behind our university program and behind our tool. So welcome to the university program from Vitech. For those of you who might not know, it's a program whereby we provide our tools, and traditionally that has meant CORE, to be used in the classroom at no cost by instructors and students. The feature set in the tool is not limited, but the size of the system that you could build, the number of entities, etc., have limits. So it's not something that you could use for commercial use, but is something that can very easily satisfy your goals and aims in a classroom setting. This year, we're doing something new. We're going to make Genesis available as well. So you would have access to CORE and or Genesis as a part of your classroom experience. So we want to welcome you to that program and encourage you to participate with us, to give us feedback, to ask us about things you might like to see that you're not seeing. So let's get started with the webinar. Our agenda today, for my part of the presentation, will be to talk about the task that we face in terms of educationally working with our students, and 2 particular kinds of students, some of the challenges in meeting our goals educationally, and then talk about why we would want to meet those challenges with models. Why would we use a tool in connection with using models? And finally, why would we choose Vitech's tools? And at that point, then I'll turn it back over to Donna, and she will give us a presentation of some of the features of Genesis, which will be the tool that's newly available in the program this year. So let's begin with our task. Of course, our task is fairly simple and straightforward at the high level. It's educating tomorrow's and today's engineers. And that can be two entirely different tasks. If you have a class of undergraduates who have not been out there in the workforce and who have not done practical systems engineering for hire, they're a little bit of a different animal than those folks who are coming back to classes, typically graduate classes, in mid-career and looking at the concepts of systems engineering from the perspective of people who, to one extent or another, have been involved with the practice of systems engineering. So we have two kinds of students and two sets of goals. The challenges that I want to talk about, though, are pretty much the same, although we approach them differently and they have a different degree of difficulty, as we would say in the Olympic world. And those two challenges are challenges with the way we think in terms of doing systems engineering and the challenge of complexity. We confront both. And we'll talk about how those are related, and we'll talk about how we approach those with respect to our two groups of students. So let's first turn to thinking. There really are two kinds of thinking that are necessary in the systems engineering, systems design world. The first is analytic thinking. This one's typically the easier for us to grasp and to use, and that's largely because analytic thinking is a product of the Enlightenment, from the thinking and approach of Descartes and others. We're taught the scientific method, which rests pretty much on analytic thinking. And the basic underlying philosophy of analytic thinking is, if you want to understand a larger whole, a system, if you will, the way to do that is to reduce the system to its parts. So we take it apart, we look at the actions and characteristics of the individual parts, and by understanding the parts, then we aggregate that into an understanding of the whole or of the system. That was the breakthrough for the Enlightenment, was the idea of using analytic thinking in a disciplined way. The other kind of thinking can be a little more difficult, and that involves synthetic thinking. Synthetic thinking understands something by looking at it as a whole, looking at its behavior as a whole, looking at its characteristics as a whole, looking at it as an entire structure. And this becomes very important in systems engineering, because what we're trying to do is to take a systems view. We're trying not to be reductionist, although the way a lot of people practice systems engineering is very reductionist in nature. And with our experienced folks particularly, this is a difficult hurdle to jump over, because they're naturally led. Many of them are trained in the beginning as discipline engineers, so they're trained as electrical engineers or mechanical engineers. They have an underlying discipline, and the very way that we organize our thinking in the engineering world is reductionist in nature itself. So we divide it up into subspecialties and we deal with limited parts of a system. But when we begin to deal with systems, and we'll talk about complexity in a minute, particularly complex systems, we have to be able to take a systems view. So if you were looking at a building, you can't just look at the plumbing plans. You can't just look at the electrical diagrams. You have to envision the building as a whole and set the building in its context and its environment. So it requires us as systems engineers to look from a different altitude than we looked at as discipline engineers. Now, the task of teaching people how to teach synthetically and to observe systemically can be a little easier with some of our younger folks because they're not so ingrained in their ways of thinking. There's a Zen koan that says the greatest impediment to learning is knowing. And that's true. That creeps up on all of us. We have to learn how to recognize and overcome that. But it's very true that the more ingrained we are in a particular thinking paradigm, then the more difficult it's going to be for us to get out of that paradigm. So taking the systems view and learning to take the systems view may be a little easier task from your students who are fresh and new to this whole concept. And it may be more of a challenge. And it's not that people so much out and out resist it as that we just simply get caught in it. So we need to recognize that with our students. The concept of analysis, of analytic thinking, and the very word analysis comes from roots in the Latin and the Greek, which essentially mean to pull apart, to take apart. It's particularly well suited to systems that don't go beyond being complicated. And being complicated means that while you may have lots of parts, think about looking at a mechanical watch, for instance. There are lots of gears and lots of little moving parts put together very intricately. But if you can tell me the diameter and the number of teeth and the degree that you're going to rotate any one gear in that setting by extrapolation, I can tell you how that's going to affect any other gear simply by tracing the cause and effect through the watch mechanism. So just like this tabletop toy that we put out that shows when you drop one ball against the others, the momentum, the cause and effect is translated through the other balls, and the result is predictable. So complicated systems are very predictable, and they're predictable because the cause and effect is very deterministic. So you essentially can draw straight lines in tracing your root causes into their effects. This gets tricky, though, when we get into the area of complex systems. Systems can be complex from a couple of different perspectives. They can become complex in that they have lots of elements related in lots of different ways to each other. So the structure can contribute to their complexity. They can also be complex in a dynamic sense. In other words, that structure will change states over time, and it will morph from one thing to another in terms of what state it's in, and it can be dynamically complex at the same time. So you can have these two forms of complexity interweaving together to make up your complex whole. The characteristic of complex systems that make them much more difficult to predict than the more linear and deterministic complicated systems is something that's called emergence. An emergence is a behavior or a property or characteristics that tend to emerge once the elements of the system are put together. If you have one molecule of water, it's not wet. If you have two molecules of water, they're not wet. But there's some point where there's a critical number of H2O molecules that you put together and you get water and you get wetness. And the wetness of the water is an emergent property. It's not predicted by looking at this molecule and that molecule and that molecule and adding them together. It emerges from the combination of those molecules into what we think of as water. That makes it difficult to predict that kind of emergence, that kind of appearance of characteristics or behaviors that come from the relationships make them much more difficult to predict. And of course, our task in engineering and as designers is that we're looking at a problem which may in and of itself be complex, set in a context that in and of itself may be complex. And we're called upon to come up with a solution system for that problem or set of problems. And the solution that we come up with may be complex as well. So we have to deal with complexity. So why is that a big deal? Well, it's a big deal because as opposed to tracking linear cause and effect, this becomes a big challenge in terms of brain capacity. It's difficult to track, to hold in our heads, to simply try to take it in and make predictions about it and use it as a part of our design concepts. So this challenge of complexity is a challenge that forces us to go outside ourselves. So why would we try to grapple with this challenge using a model? Why is a model something that could help us with the challenge of complexity? And it can. First off, it's absolutely necessary that we have a model. And we always do have a model. Some people will say, we'll talk about model-based systems engineering. There's no such thing as non-model-based systems engineering. Because if you and I can talk about something, if we can talk about a system, it's only because we have a model. Now, if we're just simply talking about a system without having formalized the process, and we'll talk a little bit about that, about how we do that. If we haven't formalized the process, then your model may be different than my model, and that may lead us to trouble. When I teach model-based systems engineering, I sometimes have the class do an exercise where I say, okay, draw a picture of a horse. And so they draw a picture of a horse and I have them shut their eyes and I say, everybody whose horse is black, raise your hand. So they raise their hand and I count and I say, now everybody whose horse is brown, raise your hand. And they raise their hands and I count. I go through several iterations of horse colors. And then they open their eyes and I say, okay, where did that picture come from? And where did your answers to the questions on what color your horse is come from? It comes from a model in your head called horse. And so if I say horse, typically given the same cultural background and set of experiences, we're going to have a general picture of the same kind of animal, but it's not necessarily going to be the same color. And it might not be the same size, and it might not be the same breed. So we always use models. That's the only way we can communicate, but we don't necessarily use a single model. And it becomes important to use a single model, and we'll talk more about that as we go. But the way that a model helps us is that it allows us to organize the elements, organize the relationships, organize the behaviors. It allows us to put together the elements of the model in particular ways, and it helps us to manage that model. So as that model changes over time, and as that model matures and becomes more and more specific, the fact that it is a model helps us to manage particularly the complexity involved. So we organize a model by creating a framework. We would call that framework a metamodel. The framework is a metamodel. If we instantiate the framework in a database, we have a schema. And we'll say a little bit more about that. But we have a way of organizing the model which allows us to plug the elements of the model, or whether that's a model of a problem or a model of a context or a model of a solution. We have a way to organize it and think about it and track it and manage the changes as we go forward. As we mature the model and we deal with particular problems in the model, we're able to use the model to manage the complexities and the interrelationships, the changes over time that happen, the changes in structure. We make discoveries about what will and won't work. So we use the model not only to organize our thinking about it, but our ability to manage the complexity. So if we're going to have a model, why do we need to use a tool? Why would we have a tool? I think the reason for the tool is twofold. For one thing, it exposes the model. So remember when I talked about the horse exercise, the reason why I got different answers from different people when I asked about the color of the horse was that the model was not exposed. They had a model in their minds of a horse, and in many ways it had similarities, but it didn't track out into the characteristics of the horse. So the model was not exposed, so we couldn't really have a plain conversation or a common understanding, if you will, of exactly what we were talking about when we talked about the horse. When you get something more complex than a horse, when you start to model an infusion pump or a missile system or something that's more complex than the whole idea of a horse, we can have a high-level model, but we can't get very far into the details, and with those kinds of systems, not far enough into the details for it to even be useful. The second thing is that that a tool helps us to maintain consistency in the model. So as we attempted to answer the design concerns and to solve the problems that we're confronting with the system solution that we're modeling, we have to remain consistent. We may introduce elements which have an impact on other elements in a way that decreases the efficiency of those elements. We need to have the model help us to be consistent as we advance it and mature it. So the first is exposure. If we use a tool, we take the model out of the heads of the people, and sometimes when you begin to talk about a solution, one person has a model of the solution in their head and everybody else has questions. Don't really understand how that would work. When we have a model and have a tool then the model in the tool allows everybody in the group to take a look at it, to see what they think about it, to determine their ideas, and we can advance the development of the model much more easily if it's visible to everybody who's involved. The second thing is that if we're going to keep the model in our heads, it's very, very difficult to remain consistent. The model is complex because what we're modeling is complex, the questions are complex, and it becomes difficult to hold that in order in our brains and to remain consistent, particularly because the model changes as it matures. And so it's hard to track all of those changes, to remember what we've done. That becomes difficult to do. So why would we use Vitech's model? Why would we encourage you to use our model, our tool, as you teach people about systems design? I think there are two reasons. One is that our model is integrated. It's not fragmented, it's not broken apart, it's not a domain-specific model. It includes all the elements of a system, it includes all the relationships among those elements, it includes all of the characteristics, attributes of the elements. So it's an integrated, what we call ERA, elements, relationships, attributes, model that allows us to get the overall systems view that we have to have in order to make the predictions and decisions that we have to make as system solution designers. So first, our model is integrated, and second, we have a meta model behind it, which has stood the test of time and provides a rational basis for folks to make decisions about how they're going to plug their elements and the relationships and the attributes into their model. In the integration, we integrate the four classic domains. In our schema, requirements are the basis of behavior, and behavior is allocated to the components. The components then perform the behavior, which is in turn based on the requirements. So you see, you establish, by using an integrated model, you can establish that bidirectional traceability, which we're looking for. And at every step and turn along the way, we can verify and validate. So we can see that traceability because the model is integrated. So we can get the systems view and we can see the traceability from the requirements for solving the problem all the way through to the instantiation by way of the behavior that's produced in the instantiation. Our meta model, and remember that the meta model is the abstract framework into which we place the elements. And the meta model instantiated in a database we call a schema. So our meta model reflected in our schema, the meta model that drives our schema, is one that allows us to put everything we need for system design. There's not really anything that's left out of the schema. So you can do all of your plugging in, set up all of your relationships, and organize and instantiate your model with the schema as the guide and the framework for that. So that's why we would use Vitech tools. That's why we would use tools to instantiate the model, and why we would use models to wrangle the complexity. So now that we have traced that course, let's take a high-level look at the new tool, or it's it's not a tool that's all that new in and of itself, but it's new to the university program. So let's take a look at Genesis. And for that, I'm going to turn the program back over to Donna.
Thank you, Zane. I'm going to take control back, and there's Genesis. So I'm going to just take what Zane has talked about and run through the Genesis University Edition so that you're familiar with it, and then give you a little, give you the way that you can start using it in your program. So here is the University Edition as it stands when you log in. Hey, Zane, you want to go ahead and mute?
Sure.
Okay, thanks. So here is the University Edition screen. As you can see, when you log in the first time, logs in very similarly to all of our products. When you first start off, it's administrator admin, and you come to this home screen. At this point, you can either open a project, create a new project, import our exported samples, or whatever you've done. I have loaded our sample geospatial library in, and I'm just going to use that as our model. So I'm going to go ahead and open that. And it's just going to take a minute to load, and it's going to come up into this Project Explorer. The Project Explorer is where you're going to be spending most of your time when you're using it. I'm just going to do a little fiddling around here. Zane talked a lot about our schema and our Metamodel. This is where the information is, and if you're curious as to what it looks like, once you have one of our products, you can go into the schema portion, and the classes pane will show you a tree view of all the projects, or of all the classes that we have. The geospatial library is based on our base schema. There is another schema out there that supports architecture development, and that is also available. I just don't have that one loaded right now. So if you're curious as to what a full port does, this is one of our new classes in Genesis, supporting the port development for SysML. You would click on the class, and it gives you a read-only view of what's what the class entails. It's got a description. It's got the attributes that you'd be filling out, any parameters that might have been instantiated, and then how it relates to the rest of your model. So it lists the relationship and the target classes. This is kind of a nice view when you're getting in there and you're trying to figure out how you're going to use this. I picked full port simply for its location, but the pieces that Zane had pointed out were component. That's the look into your physical model is right here. Function is your behavior model. And of course, requirements is right here. So each one has its unique attributes, and we can get into that. So I'm going to move over. One nice thing when you're first learning the tool is there's a feature that'll pop up the description for a class when you hover over. So when you're trying to get used to it, you can pop that on, and it'll come up and give you an idea of how to get started or how to use this class. Pardon me. As you go along, if you don't want those pop-ups to come up, it is a project, or it is a preference, a user preference. So I'm going to start at requirements. That's a standard location when you're starting to get in, because you generally know what the requirements are. You know, you're either handed those in a homework assignment, or the customer will give you something, or even in your own sample project, you're going to come up with a list of, my system's got to do X. So we're going to start looking at requirements. I'm going to jump down into specific requirements. This gives me a little more interesting view. So I'm here looking at the specific requirements. It will have a description, and it breaks down into different child requirements. And this is the refined by relationship. And so I'm going to pop up a view because, you know, we all like models and we all like views. So what I'm popping up is a requirements view. This is a SysML view, which shows you the elements, and that's a little small for me, so I'm going to go ahead and make it a little bit bigger. It shows you the requirements, and then like I said, this was broken down into child requirements, so these are the child requirements, and then these children requirements are also broken down. They could be a basis of or specify a function, a behavior, or it could specify a physical component, a physical feature, which is a component. And you can also see where we do have some verification in here. We've got verification requirements that are coming off. We can do a full verification model in our tool. So this is the requirements view. If you aren't really into SysML, you'd prefer to have a hierarchical view, you can always open it this way. And you can see where they are very similar. And I'm just going to pop that closed so we can have them more side by side. So you can see that we've got the requirements, the children, and more, the specifies component and causes risk. This has the hierarchy has a little more definition in it, but you can see that they're very similar. One is more SysML, one is more traditional, and you can use whichever you prefer. I'm going to go ahead and close. Well, actually, let me show one more thing. So say that we're going along, and I'm going to pop that toolbox back up and say that this one we want to put another requirement on. Say we know it's broken down once, but we're going to break it down one more time. And I'm just going to create a new requirement, and I'm going to say ABC rec. And I'm going to go find it now. It's going to be at the bottom of my list. And I'm just going to go here, and I'm going to say it refines that. So now you can see that that popped up over here. If I come back over to this one and find the same requirement, you're going to see that it popped up on this diagram. That's one nice thing about having an integrated model. When you're looking at different views, you're still looking at the same model. And as you update one view, you're actually updating the model underneath. And so anything that is using those same elements and relationships, those views are also going to be updated. That way you don't have to, if you're doing this in Visio, you don't have to remember, oh, I got to go back to the other diagram and I got to put this in and I have to do that. It all will be done automatically. So I'm going to get rid of this, and I'm going to come back and now say I want to go back to my component, my main component, so this geospatial component. And from here, I know this is going to be the start of my physical model. I'm going to go ahead and open that view. So all I have to do is do an open entity, and I can decide what view I want to look at. Now, these are banded in view types. The very first are open, for any element. They're very generic, the property sheet, the spider diagram, the hierarchy diagram. After that, the second set of diagrams are specific to different classes. So sometimes they'll become available and sometimes they won't. Like a use case diagram, they'll open up on a package or it will open up on a use case, but it won't open up for a requirement or a component. The third band here is the physical, the physical diagrams for my model. And so this is what I'm really going to be interested in. But let me just talk about the fourth one. The fourth one is your behavior. Now, I have a component selected. The behavior is listed. This is helped out through our tool with the model assistant. So what we have done in the recently is to add these rules in that help the engineer get going. So when you're building your physical model, you're actually starting your functional model, your behavior model underneath. And we're just doing a little bit of model connections behind the scenes. So you can actually look at the functional part. You can actually start building your functional part without having to go and do some mechanics. But here I'm looking at the geospatial library, and I want to look at its interface block diagram. So Here you see, we call it a little cartoon diagrams. I have been playing around, so there's one node that is not an image, but everything else is an image. Sometimes this is easier, especially at the higher level, when you're talking to your customers at the very start to say, hey, this is the satellite, this is your certification, this is a workstation, instead of having nodes. But this is all, can be all be tailored to your audience and what you're trying to do. So what I'm going to do is just show you how quickly I can move that and make that just an image. I'm going to just resize that. So you can put images in there. You can have it with the traditional node and lines. So here's my geospatial model. I'm not getting into the models per se. I'm just really trying to show you Genesis. Now you can see that these collectors, or hopefully you can see that these collectors are in blue. That is an indication that those are external to my system. That means that I've put them on a context diagram and I've connected them up, but they're not actually part of my system. They're external to my system. Command Center and Workstation are internal and they are black. And you can kind of see that when I look at the node and the colorings. Now all diagrams have this toolbox in the property sheet with things you can change very easily over here. And we hope you will explore what diagrams we have and how and which ones are appropriate for you and how you can modify them. Now I'm looking at my model here. This is my physical model. These are interfaces. I can also look at my links. Or I could go over and now look at my behavior. So what I'm going to do is from here with nothing selected, I'm going to go to my views, and you can see that I do have behavior views. And this is another nice way to get to your views. So views, I'm going to go over to behavior. I'm going to open an activity diagram. Now the activity diagram and the EFFBD are very similar. The activity diagram, again, is a more SysML type view. It flows top to bottom. Now on here, you can see that the items, most of them are on the edges. This just means that they are also going to some external function, so that if you make changes to it here, it's an indication that you're actually making changes to something else. So if you make a change to that item, it's actually going to impact another diagram. Now, if you don't like this top to bottom, you can either switch it by going to layout and changing that, or you can look at a slightly different view. And again, I'm going to go up to the views and I'm going to bring up an EFFBD. Now, the one nice thing, with the model being consistent among views is if I like to work in an EFFBD, but as an instructor or my instructor wants to see us as an activity diagram, I can still work in an EFFBD and do everything and then look at the activity diagram at the very end. It's not going to have the layout, you're going to have to move some items around, but then the instructor will get it top to bottom, and I've been working left to right. But it's all based on who your customer is, who's working with it, and what you're most comfortable with. We give a lot of options. Again, a lot of different diagrams that you can work from and decide to use. I'm just going to look at my list here. I'm about out. I'm just going to come down, close out, and you can, I'll look a little bit at this Project Explorer. If you look at this homepage, you do see these classes. Now, there's not as many classes as you saw on the schema side, and that's because we've broken them up into different facilities. You can modify this through the schema. We have set it to come up to essentials. These are the essential classes that we think that people are going to be using. You may decide you want a bigger set. We've got a system engineering, we've got a program management, and verification. So you can just see that these classes will update automatically as you go. Now, the one thing I forgot to do was when I was looking at my context function, I didn't bring up the simulator. So we do have the simulator, and pardon me, let's see if I can get it. There we go. There's the simulator. All of our functional models can simulate right out of the box. As soon as you put a node on a diagram, you can simulate it. Not a very interesting simulation, but it allows you to check your behavior and make sure it's working. So if I run this one is got some events that aren't able to execute, but that's a good diagnostic, and it will still display everything that could execute and what it's waiting for. And this will allow me to come through and fix my model so that it will actually execute. We've got a transcript that has a lot of interesting information on it. A lot of people will take this right over, export it to CSV and take it into Excel and do the post-processing. And as you see, I just took it out. I'm going to just put it over there and see you can, your windows are manageable. You can also close them out and then reopen them. So I'm just going to close that out. So that's simulation. We also have other ways, other connectors. We've got an Excel connector, project connector, a PowerPoint connector. We also have connections to the MATLAB solver and to Simulink. Those are all available. They're also, available to the University Edition as well as Commercial Edition. Now, I do have one question here that just popped up. And the question is, what are the limitations of the UE version? Obviously, we're putting the UE version out there for free for students and instructors. There are some limitations. One is that data cannot go back and forth between the commercial edition and the university edition. Anything that you want to, as an instructor, if you've been working with our products and you want to move it over to the Genesys University edition, it will have to come through us, and we will have someone translate it and send it back to you. Also coming back the other way, sometimes we have students who work on projects and then they want to use that as a start in their business. As Zane had said, we've got students who are professionals, and so they want to use it, and they've got CORE or GENESYS in their work environment, and they want to pull it back. They would have to send that file to us, and we could translate it and send it to them. We don't mind doing that on occasion. It's just a limitation that we've put in place. So if you're familiar with Genesys and you go to do an export, you'll notice that this export is different. We've limited the capability mostly to streamline, to help the student so that they are not as confused. So at this point, you can either be working as an individual project, you can export the baseline and then do work in progress and the database changes. So if you have team collaboration that are working on separate machines, they can use this baseline with changes, import, export. Well, obviously I'll help you if you have any questions about that. But talking about collaboration, we do have the capability of the University Edition collaborating up to 5 students at a time. So Genesys is built on a SQL database. It's disk resident, so students can collaborate on one SQL Express, installation. Let's see, what else is the limitation? There's a limit of I think it's 200 elements or entities per class, and there's like 2,500 entities per project. So that's another limitation. You have full capabilities for your connectors. You have full capabilities on the schema side. You can create users and groups to do that team collaboration. I'm trying to think if there's anything else. No, that is it. Let me check and see if there are any more additional questions that have come up. I'm not seeing any. So I hope you enjoyed your brief tour of Genesys University Edition. If you are interested in joining our program, you can go to our website, and let me pop that up for you. So if you go to our website, under Services Training is a Vitech University program. Here you would register, click this register button, and you can join the Vitech, the program. That'll get an email to me, and I will be in contact with you to do instructor forums or get you started and enrolled for the fall or in the coming semester. There are other, I also wanted to show you some good resources on here. We do have our online resources, and if you go to screencasts, you will see Getting Started with Genesis, Getting Started with Core Commercial, and Getting Started with the Core University. There will be a collection coming in here that's Getting Started with Genesis University Edition. We just haven't gotten that uploaded yet. But a lot of the Genesis, because we're not limiting functionality with the University Edition, most of the Getting Started with Genesis collection is applicable to the University Edition. Okay, so that wraps it up for today. If you have any of the questions or comments, please don't hesitate to send Zane or me an email, or you can post your questions or comments on the LinkedIn group page. Just visit linkedin.com and search for Vitech Corporation. Thank you so much for attending today's webinar. Look for information on our upcoming webinars listed on our website. Remember that at the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.